Welcome to the next installment in the video lecture series for managerial economics. And in this particular video, we're going to take a look at Chapter 10, again, the Q&As. And the first one, of course, that we're going to start with is Q&A 10.1. How does total surplus change if the movie theater described in Table 10.1 goes from charging a single price to perfectly price discriminating? So the first thing that we have to take a look at here is which of the uniform prices will the movie theater select. At a uniform price of 10, we see that the movie theater is generating $100 worth of profits from college students, $200 worth of profits from seniors, and that yields a total profit of $300. If they raise the uniform price to $20, they're still selling to 10 college students, so their profit is equal to $200. The senior citizens will stop buying completely because that $20 is above their reservation price, the highest they're willing to pay. So the total profit is equal to $200. So under this scenario on A here, on the top part, this movie theater is going to select a uniform pricing of 10 because its total profit is going to be equal to $300. Let's take a look at and compare the total surplus generated from that and compare that with price discrimination and perfect price discrimination that we were talking about previously. So if we take a look at this, we see that at a uniform price of 10, we have a profit of 200. If the price goes up to 20, the profits generated are zero, meaning the senior citizens are not buying any. So we can infer from that $10 is the highest price they're willing to pay, so they are generating no consumer surplus. So we know that the consumer surplus generated from senior citizen purchases when the uniform price is equal to 10 is equal to 0. What's the consumer surplus that is generated by college students? Well, we know that if the price raised up to $20, they would still purchase the same amount. So they would willingly pay $20 for that ticket. So we know that if they're paying 10, that they are generating $100 worth of consumer surplus. That they would have willingly paid $10 more for those 10 tickets, so that would have been $100 worth of consumer surplus for the college students. So if we take the $100 worth of consumer surplus from the college students, add that to the $0 worth of consumer surplus generated by the senior citizens, and add that to the total profit, so 100 plus 300 would give us a total surplus of 400. Let's take a look at the total surplus when we have perfect price discrimination. What would occur? Well, the movie theater would charge college students $20 a ticket, and they would charge $10 a ticket to seniors for a total profit of 400. Well, this is the maximum that college students be willing to pay. So they're generating $0 worth of consumer surplus. $10 is the maximum that seniors are willing to pay. So we generate $0 of consumer surplus. So the consumer surplus under perfect price discrimination here is equal to 400. So the total surplus does not change under uniform pricing versus perfect price discrimination under scenario A. Let's take a look at scenario B and see how to look at this. Again, which of these two pricing policies would the movie theater engage in? They want to engage in a uniform pricing policy that maximizes total profit, so they will charge $20 to college students, which will cause them to still buy 10 tickets, but the seniors will buy none because it's above their reservation price. So let's take a look at this. So we have 200 as the total profit. We need to add into that to get total surplus what the consumer surplus is. And in this instance, the consumer surplus of uniform pricing of $20 is equal to 0. being because the seniors aren't buying anything. So if they're not buying anything, they don't generate consumer surplus. And since the profits are equal to that under perfect price discrimination, again, the college students paying the highest price they're willing to pay generate no consumer surplus. So consumer surplus for the college students is 0, for senior citizens is 0. So the total consumer surplus is equal to 200. Let's compare that to the total surplus under perfect price discrimination. Under perfect price discrimination, what will occur is the movie theater will charge $20 to college students and $10 to senior citizens, and that will generate a total profit of $250. Since we're engaging in perfect price discrimination, we're going to see no consumer surplus. We're charging the highest that college students are willing to pay, and we're charging the highest that seniors are willing to pay. So consumer surplus from college students is equal to 0. The consumer surplus generated from the sale of tickets to senior citizens is 0, so we just have the producer surplus, which is 250. So under this scenario, we actually see that total surplus increases when we go from uniform pricing to price discrimination. Moving on to QandA 10.2. A monopoly book publisher with a constant marginal cost and average cost of marginal cost equals 1 sells a novel in only 2 countries and faces a linear inverse demand curve of P1 equals 6 minus 0.5 Q1 in country 1 and P2 equals 9 minus Q2 in country 2. What price would a profit-maximizing monopoly charge in each country with and without a ban against shipments between countries? So when there is a ban, what we're going to take a look at is we're just going to look at the profit-maximizing price and quantity in country 1 and in country 2 separately. So that's what we're going to do in the first part here. So we know that the inverse demand function in country 1, we know marginal cost is equal to 1, and we know the inverse demand function in country 2. So we need to calculate total revenue in country 1, which we know is P times Q. So we can insert the inverse demand function into here and multiply that by Q. And if we multiply the Q1 through, we get total revenue is equal to Q1 minus 0.5 Q1 squared. So that's total revenue, and that doesn't appear in here, but this should be equal to a Q1. So total revenue is equal to 6Q1 minus 0.5 Q1 squared. We take the first derivative, and we get marginal revenue is equal to 6 minus Q, multiplying by the 2 and then lowering the power of this by 1. And then once we know marginal revenue and we know marginal cost, we just set them equal to one another, as that is the profit maximizing condition. So we get 1 is equal to 6 minus Q1. Q1 is equal to 5 when we solve for that. And if we stick the 5 up into the original inverse demand function, we end up getting that the price in country 1 is going to be equal to 3.5. We'll do the same thing for country 2. Multiply P times Q to get total revenue. We can insert the inverse demand function into here and multiply that by Q. So we end up with total revenue is 9Q2. Again, I'm sorry that that does not appear. Minus Q2 squared. Take the first derivative, and we get marginal revenue is equal to 9 minus 2Q. We know when marginal cost equals marginal revenue that that is the profit maximizing condition, so that we have 1 is equal to 9 minus 2Q. We get 2Q is equal to, Q2 is equal to 4. And then when we stick Q, the quantity, into the inverse demand function, we get a price of 5. So when the ban is in place, you're just maximizing the profits based upon the inverse demand function in each individual country. So in country 1, the bookseller will charge 3.5 for the book and sell 5, while in the other country, they will sell it at 5 and they will charge 5 for it, and the sales will equal to 4. Now, if we have both of these countries here, we have to rewrite our inverse demand function into the actual demand function. The reason being is that if you think about this, and if you take a look at the diagram that's in your book, you will realize that for prices above 6, so for any of the prices that are above 6, the only part that we really need to concern ourselves with is country 2. Because in country 1, if the price is above 6, that the individuals will not purchase it. So for prices above 6, the only demand curve that's operable or is important to us is country 2. But for prices below 6, we are going to have to add the demand curves for country 1 and to country 2 together to get the operational demand curve. So make sure you realize that for prices above 6, the demand curve that is important to us is only going to be country 2. Once the price falls to 6 or below, we have to add the demand curves from country 1 and country 2 together in order to get that particular demand curve. And your textbook, what it has is you can see there that when they talk about a single price monopoly, you see a kinked demand curve. That represents the fact that for prices above 6, we're only concerned with country 2. But for prices at 6 or below, the demand curve is represented by countries 1 and 2, and we're adding those demand curves together. So realize that in order to answer this question, you have to convert your inverse demand functions or your inverse demand functions for each country into demand functions for each country. And then we can add those individual demand curves or demand functions together. So originally, here's our inverse demand function for country 1. All right, and all we're trying to do is solve for Q. All right, so we're adding 0.5 Q to both sides and subtracting P from both sides. And then if we multiply by 2, we end up with Q1 is equal to 12 minus 2P in country 1. We do the same thing for country 2. We're going to try to solve for Q2. So we're going to add Q2 and subtract P. So we end up with Q2 is equal to 9P. So now we have the demand function for country 1. We have the demand function for country 2. Now we can add those two demand functions together, those two demand curves, and that will give us the total demand for when prices are below 6. So if we do that, we get Q is equal to 12 minus 2P plus 9 minus P. And if we simplify that, we get Q is equal to 21 minus 3P. So now we have our demand function, and that would probably be the most confusing part of this this particular Q&A, is realizing that you have to convert the inverse demand functions to demand functions in both countries, add them together, and then you're going to see what we're going to do is we're going to come up with an inverse demand function for the summation of the two countries. So that would be probably the part that would cause most students, or the students that have difficulty, a problem, is knowing that you need to go from the inverse demand function to the demand function, add the demand functions together for the two countries, get the demand function as a summation of those two demands, and then go and convert that back to an inverse demand function. So there we go. Now we need to convert this back to an inverse demand function. So we're going to add 3P and subtract Q from both sides. So we get 3P is equal to 21 minus Q. And then we divide by 3 through. We get P is equal to 7 minus 1/3 Q. So now we have the inverse demand function. Total revenue is just going to be price times quantity. So I can take the inverse demand function here, multiply it by Q to get total revenue. I multiply through by Q, and I get 7Q is equal to 1/3 Q squared. Taking the first derivative, I end up with 7 minus 2/3 Q. Since I have marginal revenue and I know marginal cost, I can set them equal to one another. So marginal cost is equal to marginal revenue. 1 is equal to 7 minus 2/3 Q. So we have 2/3 Q is equal to 6. So I multiplied both sides by, I added 2/3 Q and I subtracted 1 from both sides. So I have 2/3 Q is equal to 6. And if I multiply both sides by 3/2, I end up with Q equal to 9. And then if I take Q and place it back into the inverse demand function, I will get 21 minus 9 is equal to 12. I divide by 4 on both sides, and I get P is equal to 4. So that make sure you realize that for that final part that you need to convert the inverse demand functions for each country into a demand function, add those demand functions together, and then go back and have an inverse demand function for the summation of those individual demands. Q&A 10.3. Let me actually read through from the textbook. It was quite long-winded. I'm just putting up here, and what's coming up on the screen is the actual question, but let me read the text that appears before the actual table in the question. Package deals are common in vacation travel. Online services such as Expedia, Orbitz, and Travelocity allow travelers to find many attractive package deals that combine a round-trip airfare and a hotel stay, or to book online flights and hotels individually. At some locations, the package price is much less than the sum of the prices for a flight and a hotel room, whereas at other locations, the package provides little savings. Paradise Vacations has 2 destinations, Hawaii and Cleveland. I'm not sure Cleveland is a paradise vacation, but for the purposes of the textbook, I guess we will just consider it to be a paradise vacation. So Paradise Vacations has 2 destinations, Hawaii and Cleveland, to which it sends its customers who live in Seattle. The table shows reservation prices for a weekend holiday for the 2 destinations for 3 customers. We assume that both hotels and aircraft have excess capacity so that the marginal cost of one or more customers is 0. And here we're going to look at the table will be coming up next. What are the profit maximizing pricing strategies for the 2 destinations? Which destination yields the bigger package deal discount under mixed bundling? So here is the table that is being recreated. So let's take a look at what they would set their pricing at. We'll take a look at each individual pricing. So for Hawaii, let's take a look at this, and we will see that, let's start at the lowest price for a flight. If they charge $50 for a flight, they're going to be able to sell to all individuals, right? Because Colin will willingly pay $50, Barbara was willing to pay $350, and Alan was willing to pay $400. So if they offer that flight for $50, they'll get 3 people to purchase it, which means 3 times 50 will be $150. Let's compare that then if they charge $350 for that flight. Colin will no longer buy the flight because he only wants to spend $50 on that flight, but Barbara and Alan will purchase it. So Barbara and Alan will spend $350 because it's equal to or less than their reservation price, and that will yield a profit of $700. Now, if this Paradise Vacations decides to charge $400, Colin won't purchase it because that's above his reservation price. Barbara won't purchase it because that's above her reservation price. So the only person who will purchase it is Alan. So charging $400 for that flight will yield $400. So the pricing strategy that maximizes the profits by this is just not bundling, but charging a single price for an individual flight is equal to $700. They will charge $300, and Alan and Barbara will purchase it. So it's $700 is $350 is the price for the flight, and that will yield $700 in profits. Let's go through the same strategy here for the hotel rooms. Let's take a look at this. So let's say if we charge $50. If we charge $50, Alan, Barbara, and Colin will purchase because the most Barbara's willing to pay is $350, and $50 is better than that. Colin's willing to pay $400, and $50 is less than that. And Alan will purchase because it's exactly equal to his reservation price. So we have 3 people purchasing at $50. So the total profit by charging $50 for the hotel room is going to be $150. Let's go up to the next highest price, $350. What will happen? Alan decides, I'm not going to buy that. I only want to spend $50 for that hotel room. I'm not spending $350. Barbara will purchase because it's equivalent to a reservation price for the hotel room. And Colin will also purchase because it is below $400, which is his reservation price, and he's willing to pay $350, which is below that $400. So Barbara and Colin pay $350. That's a $700 profit by doing that. Let's go to the highest price. Colin's willing to pay $400. Alan's not going to buy. He only wants to spend 50. Barbara's not going to buy. She wants to spend 350 at the most. So Colin's the only one purchasing. Therefore, they will have profits of 400. So therefore, the maximizing price that the Paradise Vacation should charge is 350 because that will generate $700 in profits. Let's take a look at if they bundle. All right, let's start at the highest price. If they charge $700 and they bundle the flight and the hotel room together, Barbara is the only one who's willing to purchase because that's exactly equivalent to her reservation price. Alan only wants to spend $450 for that bundle, and Colin only wants to spend $450 for that bundle. So if they bundle, their profits will be equal to $700. If they charge $450, Alan will buy, Barbara will buy, and Colin will buy. So that gives us a total profit of 3 times $450, which is equal to $1,350. So that would maximize their profits if they were just bundling. If they were bundling the flight and the hotel together, they would charge $450. They would generate 3 sales, and that would give them $1,350. What if they decided to mix bundle, meaning they would charge a bundle price and then charge individual prices? If they did that, they would charge $700. They would seek to charge the highest bundle price, and Barbara would buy, so their profits would be $700 to her. But then they would charge individual prices of $400 to Alan for the flight and $400 to Colin for the hotel room. So they would have profits of $700, $400, and $400. So by mixed bundling, their profits would be equal to $1,500. All right. And what is the bundle savings? The bundle price versus the individual prices. Remember, individually they charge $400 and $400, so it's $800 for the flight and the hotel room together. When they bundle that together, it's $700, so there's a $100 savings by bundling those products together versus having individual prices. Let's do the same thing for Cleveland. We go through the same exercise. Let's start with the lowest price. Colin was willing to pay $50. So Barbara would purchase and Alan would purchase. All right, because it's below their reservation prices. That would yield a profit of $150. Let's go to the next highest price. If they were to charge $300, Barbara and Alan would purchase. Colin would not purchase because he's only willing to pay $50 for that particular flight. So if they charge $300, they can generate profits of $600 by doing that. And if they charge $400, Alan's the only one willing to purchase. Barbara and Colin will not, and they will generate profits of $400. So their best strategy is to charge a price of $600 and sell to Alan and Barbara. Do the same thing for the hotels. We'll start at the lowest price, $50. If they charge $50, Alan, Barbara, and Colin are willing to purchase. Alan, that's his reservation price. Barbara's willing to pay $300, so she'd willingly pay $50. And Colin would have willingly paid $400, and he's paying $50, so he's better off by paying that $50 price. So they have $50 by 3 sales. That's $150. Let's go to the next highest price, $300. If they charge $300, Alan will no longer purchase because his reservation price is $50. Barbara and Colin will purchase, so that'll generate sales, generate profits of $600. And if they decide to charge $400 for the hotel room, Alan won't purchase, Barbara won't purchase. Colin's the only one who's left purchasing, so that's 400 times 1, which is $400 in profits. So Paradise Vacations is better off if they're going to charge a price of $300 for the hotel room because they will generate 2 sales, and that'll generate profits of $600. All right. If they decide that they want to bundle, what is going to be the best price for bundling? Well, if they charge $600, only Barbara's going to buy it. So profits are going to be equal to $600. If they lower the bundle price to $450, what they get is They will be able to sell to Alan because that's equivalent to his reservation price. They will sell to Barbara because she would have willingly paid $600 for that bundle. And Colin will also purchase because that is equivalent to his reservation price. So if they charge $450, they will generate 3 sales, and that will generate $1,350 in profits if they bundle. Now let's see what occurs if they engage in mixed bundling. If they engage in mixed bundling, they are going to charge $600 for the bundle and generate 1 sale to Barbara. So they're going to generate profits of $600. And then what they're going to do is they're going to charge $400 to Alan for the flight, and they're going to charge $400 to Colin for the hotel room. So their profits when they do this mixed bundling where they bundle to the highest priced individual and charge the next lowest price to the other individuals, they will generate a profit of $600 plus $400, which is equal to $1,400. And the savings that will occur if we compare the bundle price versus the individual price, the bundle price is equal to $600. They're charging $400 for the flight and $400 for the hotel room. That's $800. So the savings by going with the bundle will equal $200.